All right, for this problem, we've got a quadratic inequality. You've already seen how to graph quadratic equations and how to look at those graphically, but we're now going to look at this. We only have one variable, x. Now, you've seen when we just have one linear inequality, you've seen how to graph those on a number line in Algebra 1, and with those, you usually just have, a number line with an open or closed circle and, an arrow pointing one direction to show what region is your solution. This one's a little different because, as you know from solving um, quadratic equations, you can have more than one solution. So I'm going to go ahead and show you how we take care of that in a quadratic inequality. The first thing we do is we're actually going to go ahead and write our equation and replace our inequality sign with an equal sign. So now this actually it is just a quadratic equation. And at this point, we're going to go ahead and solve it with really any method you want. It could be completing the square, quadratic equation, quadratic formula, anything you want, graphing, finding the roots. In this case, this is a pretty obvious candidate for just factoring. As you can see, we've just got x minus 4 and x plus 1. You really want to use factoring if you can, because it helps to get those, to get these binomials, as you'll see in a little bit. It makes testing some of our regions pretty easy. So if you see that your quadratic is a good candidate for factoring, go ahead and do that. So when we factor, we're going to see that we end up getting x minus 4 and x plus 1. Now, what this means is that our solutions are x equals 4 and x equals negative 1. Now, remember, these are solutions to the equation that we have here. These are not our solutions to the inequality. What you're going to see in a second is that these just give us some important points that we need to use in order to solve our inequality. Now, as you know from graphing our quadratics and finding the inequality region, is that solutions to quadratic inequalities are regions and not just points. So these points right here help us determine which regions actually contain our solutions. So there's a lot of words right here, but follow along with me. These two numbers right here, x equals 4 and x equals negative 1, tell us when our quadratic equation equals 0. Now if you look up here, we want to know when our quadratic is less than 0. These are not our solutions. Instead, these are what we call the critical values of our original inequality. So what we're going to do right here is we're actually going to plot what we call the critical values. So I'm going to go ahead and just draw a number line right here. And I apologize for kind of the crudeness. This is 0. And we'll put 4 right here, and let's go ahead and put negative 1 right here. Now remember, these are the critical values, and because it's just less than, not less than or equal to, I'm going to draw open circles at these points, because these points are not included in our solution set. So I'm going to just draw a couple other points in here. Now, 5. Okay. Now, what these critical values do is they split our number line up into 3 regions. I'm going to call this region 1. This, between negative 1 and 4, is region 2. And this, anything greater than 4, is region 3. So anything less than negative 1 is region 1, anything between negative 1 and 4 is region 2, and anything greater than 4 is region 3. Now, the reason that we have 3 reasons is because these values do not satisfy the inequality. Okay, this is not equal to 0. They don't satisfy this. Now, what we need to do in order to determine which regions do satisfy our inequality, we need to go ahead and pick a point from each of these intervals, and we need to plug it in to our inequality and see if it satisfies it or not. If it does satisfy it, then we know that our region is part of our solution. If it doesn't satisfy it, we know that it's not. Now, what you need to do is pick a point from each. So let's just go ahead and pick number 2 right here. Now, the reason I mentioned earlier that factoring is a convenient way to solve for your roots is because since these binomials are the same thing as our equation right here, what we can do is just plug our points right into our binomials. So when we're testing -2, we can just substitute -2 for x, so we just get -2 minus 4 and -2 plus 1. Okay, and again, we're just plugging -2 in right here, and we're seeing if these values satisfy this. So -2 minus 4 is just -6, and -2 plus 1 is just -1. So when we multiply -6 times -1, we get +6. Okay, and when we plug that in here, +6 less than 0, we get that does not work. So right here, we get that this region is not part of our solution set. Again, 6 is not less than 0, so that does not work. Now, let's pick a point from our middle region. We'll go ahead and pick 0. And let's go ahead and we'll do 0 minus 4. So I'm just going to do the math right here. So we'll get 0 minus 4 is -4, and we get 0 plus 1 is 1. So now we get +4, I'm sorry, right here, bear with me, -4 as our solution. So -4 less than 0. We get that that's a true statement. So that's a check mark right here. -4 times 1 is -4. -4 is less than 0. So this region is part of our solution set. Now, last one, we do 5. So if we do 5 right here, we go ahead and we get 5 minus 4 is 1, and we're multiplying that 5 plus 1 is 6. So we get 1 times 6 equals 6. So again, 5 minus 4 is 1. 5 plus 1 is 6. So we get +6. If we plug that in here, 6 is less than 0. That does not work. So that is not part of our solution set. So the only region we get here that is part of our solution set is between -1 and 4. Now I'm going to go ahead and go to the next step here on this. This shows it a little cleaner than what I just did, but I wanted to make sure I could go ahead and explain each step before just bringing on this next step and, going through it really quickly. So you'll see that they actually chose the same points I did. They chose -2, 0, and 5. So they go through, they have their work here. They show 6 is not less than 0, -4 is less than 0, and 6 is not less than 0. So all of this work is what I just went through explaining. So if you're having trouble understanding what these equations are, you can just go back and follow through what I just did. Now, since our solution set is between these 2 points, the way that we would write that is as an inequality is x is greater than -1 and less than 4. This is an AND statement because we need both of these to be true. X has to be greater than -1 and less than 4. Now, I had this question a lot in class, and I want to make sure everyone understands. When we get our two binomials, 4 and -1, there's no guarantee that our solution set is always going to be between these 2 points. You can test your points and your regions. You might find that your solution set is here and here, so it does not include this middle part. Each time you have an inequality, you have to find the critical values and test all 3 regions that your number line is broken up into. It's imperative that you do that because you never know what regions are going to be in your solution set. It's different for each problem. Okay? If you have any questions on this, you can rewatch the video, or you can come in and see me during tutorial or after or before school for extra help.